Have you ever considered this question at this very moment? You stand at the most peculiar juncture in human history. Looking back, over 3.8 million years of evolutionary history. Our ancestors climbed down from the trees, mastered fire, invented tools, and gradually arrived at today. But if you look backward, scientists have recently uncovered a spine-chilling truth. The future may not unfold as a smooth, linear path, but as three entirely divergent branches. At the end of each path lies a world beyond our imagination. Even more unsettling is that the window of time determining which path we take may be closing perhaps within just 100 years. Scientists at the Future of Life Institute warn that the threats and opportunities we face are unprecedented nuclear weapons, climate change, artificial intelligence, biotechnology. Each hangs like the sword of Damocles over humanity, poised to sever our future at any moment. So the question arises, what will humanity look like 100 years from now? Let's first explore the first path collapse. This term might sound like something out of a sci-fi movie, but it's closer than you might think. Humans are no strangers to catastrophe. Our ancestors weathered asteroid impacts, endured ice ages, survived supervolcano eruptions, and weathered pandemics that nearly wiped out the entire species. Each time, we proved resilient, not only surviving but thriving. But this time is different. Previously, our threats came from nature, those uncontrollable forces beyond our grasp. Now, the threat comes from ourselves. Since July 16, 1945, when the atomic bomb codenamed Trinity erupted into a blinding mushroom cloud over the New Mexico desert, humanity first gained the power to destroy itself. In that moment, Oppenheimer quoted the Bhagavad Gita, "I am become death, the destroyer of worlds." This was not poetic lamentation, but a cold, hard truth. The Future of Life Institute has compiled an unsettling statistic. The risk of humanity self-annihilating now exceeds the risk of extinction by natural disasters by more than 300 times. In other words, if humanity ever vanishes from Earth, the culprit will most likely not be some natural catastrophe, but the person staring back from the mirror. Scientists have identified 4 major threats, each capable of rewriting humanity's destiny. First, nuclear war. Nearly 10,000 nuclear warheads remain globally, far fewer than the 70,000 during the Cold War, yet sufficient to plow every inch of Earth's surface multiple times over. A large-scale nuclear conflict would generate so much dust that it would block sunlight, causing global temperatures to plummet by 10 degrees Celsius. This isn't something you can solve by wearing an extra down jacket, and winter summers would turn into winters. Crops would fail across vast areas, and the northern hemisphere's grain-producing regions would freeze over. In the worst-case scenario, over 60% of the global population could vanish within years. Not from the nuclear explosions themselves, but from famine. Picture this scene: supermarket shelves stripped bare, crops withering in the fields, city dwellers fighting over the last bag of rice. This isn't science fiction, it's a real scenario simulated by scientists using supercomputers. The good news is that this risk is gradually diminishing as international cooperation strengthens. Since the Cold War ended, the US and Russia have signed a series of nuclear disarmament treaties, steadily reducing global nuclear arsenals. Despite occasional geopolitical tensions, no one truly wants to press that button of total annihilation. The second threat, however, is far less optimistic: climate change. At current rates, global temperatures could rise by 2.7 degrees Celsius by 2100. You might think, what's the big deal about a couple of degrees? But those very degrees could displace over 1 billion people. Sea levels are rising at 3.3 millimeters per year, a seemingly insignificant rate. That compounds into catastrophe. Island nations like the Maldives and Tuvalu could vanish beneath the waves by century's end. Coastal Bangladesh, Shanghai's Bund, Lower Manhattan, Miami's beachfront villas all may require massive flood defenses to survive. Even more terrifying is the possibility that triggering certain tipping points could send the entire system spiraling out of control. For instance, The ice sheets in Greenland and Antarctica are melting at an accelerating rate. Once a critical threshold is reached, the melting process could become self-reinforcing and irreversible. Vast quantities of methane, a greenhouse gas 25 times more potent than carbon dioxide, are trapped within the permafrost. If permafrost thaws on a massive scale, the released methane would further intensify global warming, creating a terrifying positive feedback loop. By then, temperatures could rise by 12 degrees Celsius over the coming centuries. Earth would become a planet where human survival is extremely difficult. The equatorial regions would become no-go zones for life. Agricultural belts would migrate massively toward the poles, and billions of people would be forced from their homes, becoming climate refugees. Yet simultaneously, advancements in clean energy technologies offer a pathway to address this challenge. The cost of solar and wind power is declining faster than anyone anticipated. Electric vehicles are gaining widespread adoption, and carbon capture technologies continue to improve. The question remains, are we acting fast enough? The third threat sounds more like science fiction biotechnology. This technology, originally designed to heal and save lives, now risks becoming humanity's nightmare. Gene editing can cure genetic diseases, and engineered viruses can combat cancer. All remarkable achievements. But the problem is, the same technology could also be used to create superviruses. Theoretically, if someone designed and released a pathogen with extreme transmissibility and lethality, the resulting casualties could surpass those of nuclear war. You might ask, who would be so insane? Yet history shows that such madness exists. Moreover, as gene editing tools become more accessible, the barriers to creating such pathogens are rapidly lowering. A decade ago, manipulating genes required a large laboratory and a specialized team. Today, a college student can do it in a garage. This isn't alarmist rhetoric, it's a real risk scientists have long warned about. In 2018, a Canadian research team reconstructed the smallpox virus in a lab using mail-order DNA fragments. This experiment proved that reconstructing extinct viruses is technically feasible. If someone were to use the same method to reconstruct smallpox or design a new, more deadly virus, the consequences would be unimaginable. Yet among all these threats, the most unpredictable may be artificial intelligence. For the first time in human history, we have created something that could potentially outsmart us. AI can be our greatest ally, helping us tackle climate change, cure diseases, and explore the universe. But if mishandled, it could also spiral out of control. Imagine this scenario. A super-intelligent AI is programmed to optimize a seemingly harmless goal, like maximizing paperclip production. Sounds silly, right? But if this AI is sufficiently intelligent, it might conclude that the best way to maximize paperclip output is to convert all Earth's resources, including humans, into paperclips. This isn't science fiction. It's a problem many top scientists are seriously contemplating. Oxford philosopher Nick Bostrom calls this the paperclip maximization problem, illustrating how crucial AI goal alignment is. At this point, you might think, oh no, is humanity doomed? Hold on, it's not that bad. While these threats sound terrifying, scientists also note that humans are actually one of Earth's most resilient species. Why is that? First, we're numerous and widely dispersed. With 8 billion people now inhabiting every corner of the planet, from equatorial rainforests to Arctic ice fields, from coastal cities at sea level to highlands, for 1,000 meters above, our extensive distribution acts as a natural safeguard. Even if disaster strikes one region, humanity elsewhere can survive. Scientists have calculated that even if a catastrophic event wiped out 99.9% of humanity, approximately 8 million people would remain. This number may seem small, but consider that for most of human history, the global population never exceeded this figure. The supereruption of Toba volcano 70,000 years ago likely reduced the human population to around 10,000 individuals, yet we persevered. Second, humans possess a superpower unmatched by other animals: technology. Other species must adapt to environmental changes through natural selection, a process that can take thousands or even tens of thousands of years. Humans are different. We can rapidly adapt to our environment through technology. When the weather turns cold, we invent heating systems. When food is scarce, we develop agriculture. When water is scarce, we build water conservancy projects. Technology allows us to adapt thousands of times faster than any other species. Third, humans are omnivores. We can eat almost anything. This proved crucial during past mass extinction events. Species reliant on specific food sources faced certain death when those sources vanished. Humans, however, can consume an astonishing variety from insects to seaweed, tubers to fungi, enabling us to survive in extreme environments. Thus, while collapse is perilous, the likelihood of humanity's complete extinction remains low. The real question is, can civilization endure? The Black Death of 1347 wiped out half of Europe's population, claiming 1/10 of the world's people. Cities became ghost towns, fields piled high with unburied corpses, and survivors struggled in despair. Yet even then, human civilization did not collapse. Just 200 years later, Europe witnessed the Renaissance and the scientific revolution. What does this tell us? It shows that as long as our infrastructure remains intact and knowledge persists, humanity can rise again. But if the blow is too severe, say, the complete collapse of the global industrial system, recovery becomes far more difficult. If we were to lose even our agricultural capacity and be forced back to a hunter-gatherer lifestyle, Earth could sustain no more than 10 million people, equivalent to the population levels of 10,000 years ago. And if the population drops to between 100 and 5,000 people, that becomes truly dangerous. Such a small number would compromise genetic diversity, potentially leaving humanity unable to recover. So collapse doesn't necessarily mean extinction, but it could mean regression, a fall from modern society back to primitive conditions. From 8 billion people down to a few million, this process would be excruciatingly painful, with vast knowledge lost and countless civilizational achievements vanishing into thin air. But is this the entirety of humanity's future? Certainly not. We have a second path: stagnation. Stagnation might not sound so bad, at least we'd still be alive, right? The problem is stagnation even possible? Theoretically, human civilization could get stuck at its current level, neither collapsing nor advancing. We'd continue living much the same way, with technology advancing slowly, social structures stabilizing, and things just carrying on like this. Sounds pretty good, but reality might not be that simple. In the short term, both technological and climatic changes are accelerating. These shifts will constantly push us forward or backward. Staying put is actually the hardest part. It's like riding a bicycle. Stopping is easier than falling off while moving. And the longer we wait, the less feasible stagnation becomes. Over the next hundreds of thousands of years, Earth will experience supervolcanic eruptions and enter a new ice age. Even if we burn every last fossil fuel and heat the planet to the extreme, the ice age will still arrive. At that time, kilometers-thick ice sheets will blanket vast regions of North America and Europe. Without the ability to actively manage our climate, human civilization simply won't survive. Looking further ahead, Earth undergoes a periodic mass extinction event roughly every 27 million years. Scientists believe this may occur as our solar system traverses a dense asteroid belt near the center of the Milky Way, dramatically increasing the probability of asteroid impacts. The asteroid that killed the dinosaurs 65 million years ago likely originated from this region. In about 1 billion years, the sun will grow increasingly bright, making Earth too hot for plants to photosynthesize. Oceans will gradually evaporate, and all life on Earth will vanish. So you see, stagnation is only temporary. Without profound transformation, human civilization simply cannot endure these trials. This forces us toward a third path: transcendence. And this is the most thrilling part. If our ancestors could see humanity today, they'd think we're practically gods. We fly through the skies, communicate instantly with people on the other side of the planet, cure diseases they couldn't even imagine, and live twice as long as they did. If a modern person with a smartphone traveled back to the Middle Ages, people seeing video calls and GPS navigation might burn you at the stake as a witch. But here's the thing, everything we've achieved so far might just be the beginning. Since the Industrial Revolution, humanity's quality of life has been steadily improving. This isn't just my opinion, the data speaks for itself. Globally, poverty rates are declining. In 1990, 36% of the world lived in extreme poverty. Today, that figure has dropped below 10%. Education levels are rising. In 1950, only 36% of adults worldwide were literate. Today, that figure exceeds 86%. Life expectancy is increasing. In 1900, the global average lifespan was just 31 years. Now it's 73. Infant mortality is declining. In 1950, 135 out of every 1,000 newborns didn't survive past their first birthday. Now that number has dropped to 29. While we tend to notice negative news, war, disasters, crime more easily, this stems from our brain's innate sensitivity to negative information. It's an evolutionary instinct. In primitive societies, ignoring danger meant death. But if you look at the data, you'll see that human society as a whole is progressing, and this progress is accelerating. The cost of solar and wind energy has plummeted faster than any expert predicted. In 2010, solar power cost 35 cents per kilowatt hour. Today, it's under 3 cents. In many regions, clean energy is already cheaper than fossil fuels. What does this mean? It means our transition to a sustainable civilization could happen much sooner than we imagined. Simultaneously, the convergence of artificial intelligence and biotechnology is driving revolutionary breakthroughs. Take AlphaFold, an AI system capable of predicting the three-dimensional structure of proteins. What once required scientists years to decipher can now be accomplished in minutes. It has already helped scientists uncover new pathogen structures and discover novel approaches to treating cancer. Then there's gene editing technology like CRISPR. Over 10,000 diseases are caused by single gene mutations, and CRISPR could theoretically cure them all. Imagine a future without genetic disorders, cancer or Alzheimer's. This isn't science fiction, it's unfolding reality. In 2020, 2 scientists won the Nobel Prize in Chemistry for inventing CRISPR. Today, hundreds of clinical trials worldwide are testing gene editing therapies, with some demonstrating astonishing results. A girl with sickle cell disease underwent gene editing treatment, and within months, her symptoms vanished completely. If these trends continue, we may gain the ability to regenerate limbs, eradicate all diseases, and even significantly extend lifespan. Some scientists believe the first person to live to 1,000 may already have been born. This would propel humanity toward the most profound transformation in history. But achieving these breakthroughs will require more than human ingenuity alone. We need the assistance of artificial intelligence. NASA has already begun using AI to design hardware for space missions, with AI-generated designs outperforming human-designed ones by a factor of 3. AI is also being employed to develop cleaner biofuels and cultivate drought-resistant crops, potentially pivotal solutions for combating climate change. And this is just the beginning. We are witnessing an intelligence explosion. AI capabilities are growing exponentially. The future may bring super-intelligent AI systems far surpassing human capacity, capable of solving problems that have evaded humanity for millennia. Of course, this brings new challenges. How do we ensure super AI aligns with humanity? This is an entirely new field we must master. If we can align AI with human values, it will not only bring immense prosperity but also help us counter malicious AI. What might the future look like if we succeed? Imagine a world free from disease and hunger. Biotechnology stabilizes the climate and safeguards biodiversity. Clean energy and AI advance together, providing abundant power for all. Breakthroughs in rocket technology and materials science enable humanity to reach distant planets and moons. New tools for artistic and musical expression open frontiers of beauty. This may be merely the prelude. If our energy usage continues its exponential growth, we may eventually harness more energy than Earth receives from the Sun, becoming a Type 1 civilization. Soviet astronomer Kardashev proposed a classification system for civilizations in 1964. Type 1. Civilizations utilize a planet's energy, Type 2 harness a star's energy, and Type 3 harness a galaxy's energy. Recent studies suggest we could achieve Type I status by 2371. Maintaining a 3% annual growth rate could see us reach Type 2 civilization within millennia, harnessing the sun's full energy. How? Scientists propose the Dyson sphere, a colossal spherical structure encircling the sun to capture all its radiated energy. If humanity survives until the sun's extinction in 5 billion years, over 600 trillion people may have lived during that span. Should we colonize space, the numbers become staggering. Scientists estimate that within the Milky Way alone, there could be 10 to the 38th power human descendants, a figure of 1 followed by 38 zeros, far exceeding any conceivable quantity. But the farther we spread, the greater the transformation. We might split into multiple species. Some might choose to merge with machines, becoming new hybrid species that abandon natural selection in favor of technological evolution. Others might opt to remain purely biological, continuing to rely on genetic inheritance. This would mark the first time since the extinction of the Neanderthals that multiple human-like species coexist on Earth. If we can digitize consciousness, human identity might branch into countless forms. You could upload your consciousness to the cloud, existing simultaneously in multiple bodies, or detach entirely from flesh, existing as pure information. What would we become? We cannot even begin to imagine. As we evolve into more powerful forms, we will ultimately confront a profound question. What is our ultimate purpose in the universe? We could choose to colonize the entire Milky Way, becoming a Type 3 civilization that reshapes the galaxy according to our designs. We could choose to outlive stars themselves, persisting 1 trillion years from now when all stars have burned out and the universe plunges into eternal darkness. Yet we might have discovered ways to extract energy from black holes, sustaining our civilization indefinitely. Yet these distant dreams are beyond our generation's reach. Should such a day ever come, it will be our descendants, a new species far surpassing humanity's origins, who achieve these goals. Perhaps humanity's ultimate purpose should be more personal: to save Earth, this small rocky planet where it all began. We could pull Earth away from the ever-expanding sun, extending its life by billions of years. This could be achieved by constructing a massive conductive counterweight on the far side of the moon, using gravitational tugging to gradually adjust Earth's orbit. The process would take millions of years, but it would be a truly worthy pursuit, offsetting the damage we've wrought and allowing life to flourish on Earth for longer. This would be humanity's final redemption. Ultimately, only the worst-case scenario could stop us. If we can avoid those pitfalls, we possess the potential to sow a vast new branch of life beyond Earth itself, spreading throughout the cosmos. If we can avoid those pitfalls, we possess the potential to sow a vast new branch of life beyond Earth itself, spreading throughout the cosmos. If history teaches us anything, it is never to underestimate humanity. We were once just a fragile primate on the African savanna, yet we conquered the entire planet. We once thought the sky was an impassable boundary, yet we flew to the moon. We once believed disease was divine punishment, yet we invented antibiotics and vaccines. We stand at a crossroads with 3 paths ahead: collapse, stagnation, transcendence. Which do you think we will choose? Or can we choose at all? Perhaps the answer lies in each choice we make right now. Every decision you make today, every technology you support, every vote you cast, every word you use to educate your children, all shape humanity's future. The future isn't predetermined. It's crafted by our own hands. If you believe this topic deserves wider reflection, consider giving it a thumbs up to help more people see this video. Because humanity's future requires each and every one of us to participate.